hours. Right. Well, it's 2 hours UTC. It's time for astronomy data live. So come on in. Come on in. Virtual where we gather together practically every day and sit around with our consumable of choice and talk things a little while. So yeah, I hope everybody's doing well out there. So he was on. He was having difficult. So he's trying. I do see that we've got on the page.
Hey, Cosmic. Hey, everybody.
All is well.
Hey, Uncle Bill.
Uncle Bill, check. Oh, in the chat, yellow, as he does. Yeah, this is a very casual get-together of friends every day to talk all things astronomy and space and audio stutter, audio. Also have to check in.
Yeah, you're cutting out a little bit here too.
Oh, am I?
A little bit.
Okay.
Yeah.
Well, maybe it's possible. Does that seem any better? Maybe.
Yeah, it's better just now. Yeah.
Right.
I would say keep going.
Sounds like a mic connection. So yeah, that is well, that's just the story of my life. Slowly losing connection. So yeah, we sit around, look at astronomical things, talk about astronomical things, spacey things. Fun tangents from time to time. That's great. That's really, really great. So right after your live stream, got together and watched. I guess that was live, a live broadcast of the of a sort of a presentation and then a Q&A thing about the Deep Space Network, and wow, I was impressed. I don't get impressed all that much or all that often. So yeah, Bobby, hey, you're back.
Cosmic.
Hey, so I'm still hearing an echo, I think.
Okay, I'm going to turn down the Bluetooth volume.
Yeah, maybe. No, I guess it's gone. Well, I can hear it a little bit.
Okay, I might be okay, you want to know something? I never plugged up the Bluetooth speaker, so that's probably going to be it.
Anyway, so in fact, the two people on the panel right now were and Atta, who is still on the road and checked in to a rabbit. I thought that was just extraordinary. So yeah, but watch that, and yeah, I'd like to hear what you thought about that. It's wow, yeah, that they were making all of these plans for all these improvements and stuff. So chime in. What do you think about that?
I thought it was very interesting. Just watching the footage they showed about the construction was was pretty interesting too. All the concrete they poured with that thing and how they set it up.
Now,
Yeah,
what were we talking about again?
last night's rabbit session where we looked at that presentation on the Deep Space Network, the radio telescopes. What'd you think of that, Bobby?
Okay. I think the way that the way the technology goes, I think this is like really great to get so many information from those spacecrafts and then pull them all in and then work the data out so it can be made public. I think that's a great idea.
Yeah, I think I mean they're I guess by 2025 they will have an optical component added to these radio telescopes in order to detect. Well, I think another instrument is going to shoot like a laser beam or something. And he gave a wavelength. It was 1550 nanometers, which is 1.55 microns, which is, pretty far towards the infrared.
I'd like to know, like, what's the letter going to be? Like, I know, like, somewhere around next week we're going to have our first frost. Right now it's about 52 here.
Yeah, I think, so, they're going to be able to do optical communication with laser beams. So, yeah, that's pretty amazing. Pretty amazing. So what else? I'm
and
probably
they're saying they're not going to use any internet-oriented stuff. They're just going to use, like, traditional radio waves and stuff. I think that's pretty darn good.
Yeah, and I thought that I don't think there was one question that wasn't like really, really interesting. The questions were really, really great. So that was nice. I don't know how they did that. So, but I thought all the questions were just really, really great. And so I guess part of their other plans, other than incorporating this optical communication system, they're also going to be adding to each site. So there's 3 sites in the world. They're going to be adding, I believe, 4 new 34-meter radio telescopes at each of these sites. So they'll have 4 more of them. I guess they do have just a total of 12 right now. They have 3 70-meter telescopes, and then 9 like 30-meter or 35-meter, something like that, telescopes. So that's another thing that they're going to be doing. And in fact, they've constructed the first one. Is that the time lapse thing that we saw?
Yeah, I think that was one of the new ones they were putting up.
Yeah. That time lapse was kind of trippy, but it was just a little weird, but it was really, really neat to sort of see the entire construction, right, from dirt to telescope that's pointing around, and I wonder if they've actually put it to use yet. I'm not quite sure. So, but yeah, so they'll be adding adding that, and with these 4 new ones, they'll actually be able to combine all their light. So those 4 will act as if they're a single 70-meter telescope. So it's yeah, I think that's great. So yeah, very, very cool though. Really, really great presentation. That one guy, shoot, I don't remember his name now, but man, that is the kind of guy that I would love to work for, right? Wow.
Yeah, he seemed like a good guy. He was really smart. I mean, he knew everything about like all of that stuff.
No, I know. He was just banging out the answers like he knew. So yeah. So that was a good presentation. A lot of the NASA presentations are sort of stagey and scripted and all of that. But this, I'm absolutely certain, that it was scripted to a certain extent. But yeah, coming back with those answers and stuff was great. It was really, really great. So yeah, detailed answers and yeah, and I think they answered every single one, right? There wasn't an instance where it's like, well, I don't know, or we're not going to talk about that, or nothing. They were just like bang. So pretty cool. Oh, Bobby has dropped off the panel, so he's still working on things. It looks like.
Well, and going back to the part about them getting the optical, I had never seen or heard of them doing something like that, where they're installing, regular optical mirrors right into the radio telescope so they can gather both at the same time. I guess it makes sense, but boy, it wasn't something that would occur to me that you could actually do.
Yeah, and I'm not sure if they would necessarily do that at the same time. I think the telescope is basically just a structure for the optics. I'm surprised that the structure itself can support the extra weight, because they didn't give any specs on the size, but it looked like it was segmented, and it looked like maybe it was about a third of the way out. So maybe, a third of the way out, if that, if what they have there is like a 35-meter dish, then a third of the way out is like 11 meters. So a 22-meter diameter telescope, yeah, I don't know, that looks a little big. So pretty interesting though. Yeah, I guess they're going to be doing some, I don't remember exactly. They're going to be able to do some tests. I don't know if they're going to use this system, so we're going to have to wait, or if they're going to set up something else. I'm not exactly sure about that. All right, Bobby's trying to come back in. I see. There he is. You're back. Can't hear us. Can't hear you. Cannot. He cannot hear us. Oh, there we go. Are you back?
Well, yeah, sorry about that. My computer crashed for some whatever reason.
Sometimes they like to do that. I sure wish that I had, some kind of reset button. Just sort of, and things would just sort of, reset themselves. Yeah, I think that'd be nice. So yeah,
Something I felt the regrets one time, killing a gateway computer one time. I kept banging on it, kept banging on it, trying to go faster, and then the next thing you know, the hard drive don't want to run.
yeah, yes. If you bang on a hard drive, it will eventually stop, for sure.
Yeah, but thank God this computer doesn't have any movable parts. All of them is like solid state.
Nice. Yeah, everything's going to solid state, and there's nothing wrong with that. Nope. Absolutely nothing. All right. Well, cool. Yeah. So it's really, really exciting what is going on with the deep space network. They're sort of anticipating the future, and trying to be there with as much sensitivity as they can muster, and as much quality as they can do. And wow, it really seems like they're doing some cool stuff. So yeah, it was a nice presentation.
Yeah, and it shows that even if we get really good at space telescopes and those kind of things, we can still do some good science with scopes that are firmly planted right here on the Earth.
Yeah, and observing in the radio allows for that. The atmosphere is completely transparent in the radio. So
now, do you have to have a degree of astronomy and radio astronomy to work with them?
Well, that helps, but it's not necessarily a requirement.
I would think engineering background would be very good to work on those kind of projects.
Absolutely, yeah. There's a lot of hardware that needs to be designed and tested. Lots of software too, tons and tons of that. So yeah. You don't have to be an astronomer to be involved with that kind of stuff. So yeah, very, very true. So yeah, very, very cool stuff that is going on. They all really seem to be having a great old time. So that is what actually makes me the happiest, is to see people just having a great old time. So I wish that for everyone. So yeah, and they seem to be doing it. So good on them, for sure. All right, well, cheers. I'm almost halfway through this. Anything else interesting in the astronomical world? I need to check the chat here too, really quick. There we go. Okay, cool. Anything else interesting going on out there? It's yesterday I failed to mention, so I will mention it today, because technically this is the 10th of November 2018. But at least where I am here, southeastern Arizona, United States, I'm 7 hours behind UTC, which puts me right now at 7:19 p.m. Mountain Standard Time. And on November 9th. And November 9th is Carl Sagan's birthday. So happy birthday, Carl. Born in 1934, I think. Something like that. So yeah, let's see.
Happy birthday, Carl.
I just wish I have a Google Home to tell you that.
Yeah. So he was definitely the fuel that I didn't necessarily need, but he he was definitely fuel for me. Cosmos came along at the perfect time. I think I was like 11 or 12 or so. So very impressionable. Um, uh, really, you know, at that age, really into nerdy stuff, right? All the nerdy stuff. So focusing, of course, on all things astronomy. So yeah, when Cosmos came out, that was just like, I mean, I went into orbit, right? That's exactly what I needed to, shoot on up at least into orbit and get a nice view. So yeah. So yeah, great show, great 13 episode show. Um, Somewhat outdated now, somewhat. Um, but no, he laid it all out really, really well. So what else? You guys have any thoughts on Carl Sagan?
I think like Carl Sagan, if it wasn't for the Cosmos series, I think we'll never would understand how great the universe is and stuff. And having teaching Neil deGrasse Tyson about those things, that I think that was a great thing. Running from one end to another, that was pretty darn good. And don't get me wrong, Neil deGrasse Tyson's a good guy, just like Carl Sagan.
Yeah, I've got really, really mixed thoughts on Neil deGrasse Tyson. He's sometimes he can be sort of a goof, and I don't know, it sort of puts a bad name on astronomy. I think a little bit. Um, I think he gets. I mean, he gets really, really excited, right? And he wants to talk about things, and he's developed this delivery, which I don't, for me is like it's a little off-putting. Um,
To be true, I'm actually am an optimistic guy, and when I think like when he thinks it's a good thing to watch and stuff, I'll just watch it just to be watching it.
yeah, and that is completely cool. So yeah, I saw an interview with him on this YouTube channel called London Real, and that I think is sort of the real Neil deGrasse Tyson. So go over, check out London Real, and look for Neil deGrasse Tyson, and you'll see him in sort of a completely different way. When I saw that interview, that sort of put me on the fence again about him, because until then I was like, well, this guy is doing a good job, but he's trying to be funny. Oh, hello there. Hi.
Oh,
Hello.
hello! I was looking at Cat's butt.
Thanks for the view. We all appreciate that.
Tyson had a TV series that was very short-lived a long time ago. I can't remember the name of it. I can probably look it up and find it. But that was before.
It Star Chat?
No, this was. It was back before that, and he was basically just talking science. He hadn't gotten into the thing he does now, where he likes to inject humor, a lot more humor along the way, and he was more serious about it. I'll look it up and see if I can find the link. I was watching it on Netflix, I think.
Oh wow. Okay.
Now,
Yeah.
just out of my curiosity, I usually thought like Carl Sagan was the same thing. I mean, like both Carl Sagan and Neil deGrasse Tyson are like very fun guys and stuff.
Yeah. I mean, I think Carl Sagan did. I mean, he certainly did have a sense of humor. It was just a little. Uh, uh, it wasn't as sort of in your face.
Okay. And I know welcome Andy Cowley in the chat. I think he was on the SWL channel as well earlier today.
Hey there, Andy. Nice to see you there in the chat. I've got a friend here walking around. Come on, move along. I think what's happening is that I'm being summoned to do my duty here. So, well, I don't know what he's doing. All right. Well, yeah.
It's really great to have fun, but don't be like a smartass of it.
Yeah. Anyway, you know, would I necessarily want him as sort of the public spokesman for science and astronomy? No, not really. Can I think of anybody else? No, not really. so yeah, I think he's fine, and I think I think his heart is definitely in the right place, and so I'm like, yes, just follow your heart, and that's all you need. All right, well, cool. Let's see what else. What else is here? I noticed that posted a paper about some kind of crazy white dwarf stuff. What?
Yeah, the white dwarf, that's similar in size to what our sun will end up as, and it just ended up having this ultra hot atmosphere and magnetosphere, like more than they had expected and more than they had thought they'd seen in the past. So it was kind of an interesting thing.
I was.
And this, they said this discovery tells them that shows evidence that a large fraction of white dwarfs harbor magnetic fields. What else did they say about it?
Yeah, so it's a topic from astronomy.com. It says ultra hot metals swirl around its highly magnetic drum. Is that what I'm looking at?
Yeah.
All right.
And I think I put both the news story I found on Astronomy page and the actual paper link in the Discord.
Yeah. I think when I
read the paper, and some of the stuff in the paper goes over my head, but
yeah, well, that's a good place to be, for sure. Just a little bit, though. Can't be too far out of reach. So, yeah, just pretty interesting. They are looking at these absorption lines in the spectra that are like, seriously ionized atoms, right? They're talking about carbon 5 which is 4 times ionized carbon, right? Carbon is 6. So C5 has 2 electrons. It's supposed to have 6, right? C6 has 1 electron. So yeah, these are extremely ionized atoms. You've got this electron soup in these extremely charged carbon atoms flying all over the place, and you've also got nitrogen, oxygen, neon, and they're all very ionized. I mean, oxygen 8. Yeah, that's all but one electron left. So, yeah, that's some serious ionization. And I guess the only way that they can explain it right now is if you have a temperature of like 1,000,000 degrees Kelvin, which, it's like, well, you can rule that out. So, got to be something else. So, yeah, it's a pretty complicated paper, for sure. White dwarfs are very, very cool, though. If it's sort of all of astrophysics in sort of one little ball. Yeah, you can do almost everything with a white dwarf. So very, very cool objects. I'm not necessarily convinced that they are what we think they are. But yeah, who knows? Who knows?
I'm just skimming around the paper now on my tablet.
Cool. Yeah, I liked figure 1 here. So this is just showing that it's actually varying in brightness, right? That's what this top plot shows. Is that periodically, with a pretty good period, I think they actually say here. Yeah, like 0.484 days. So that goes from there to there, and that's called one phase, right? It goes from one phase goes from 0 to 1, and then 1 to 2, and on and on and on. So they're just showing 2 phases here. As you can see, they actually just replotted it twice. So, but that's fine. That's just to show that things are connected, and yeah. So they also plotted these things called equivalent widths, which are we should probably look that up to see exactly what that is. But it's essentially, let's go down to the spectra here. And these spectra are very nice, gotta say. So let's just do it on this one. A reasonable way to sort of understand the measurement of equivalent width is, say that you take this absorption line here, right? And you sort of do a fit to it, right? So get rid of all the noise, just make it nice and smooth, and then sort of go at the peak here, or at the bottom, and
now this question came into my mind. With all the stuff that we can get at space, can that stuff can come to Earth at any time, or what?
I'm not quite sure I understand your question.
Like whenever those elements get synthesized and get sent to interstellar space, what's the possibility that those elements can hit the Earth?
Oh, well, as the theory goes, right? The reason why we have carbon and oxygen and nitrogen and all that here is because of these kinds of objects, making this stuff, and eventually, that stuff is going to find its way into into dirt, and then into plants, and then into animals, and then into us. So yeah, it's an interesting path. But yeah, this is at least what the theory says is that this is how those kinds of things are manufactured, and then how they're dispersed is just a lot of time. I guess just a lot of time. So the equivalent width is just sort of, if you go halfway between, say, this line and the peak, that width is this width right here, and that's going to be measured in angstroms. So, and that's not an exact definition, but it's a good approximation. So what they're showing here, let's see, can I go back? Are these equivalent widths at different wavelengths, looking at various spectral features. So 60 angstroms. Let's see what that is. They don't say what that is.
It's funny that we can look at that paper without going to the PDF first. I think that's a good thing. I'm just using the PDF.
Yeah. I just I didn't actually see a PDF link, so I saw that the paper was
what you
there.
want to do? You want to zoom it back out to normal, and there should be a link there.
Oh, okay. Yeah. Anyway, I think this is the 60-60 line that they were talking about. So you can see how, and this is the phase angle, right? So this is going from 0 to 1, right? That's this plot. The orbital phase, right? 0 to 1. So this top one is near a phase of 0. And then here's a phase of 0.38, 0.56, 0.7, 0.86. And you can see very clearly that these things change. And so that's what
interesting. They can find all that with all those dips within the spectrogram.
I know. Spectra are very complex beasts, and it takes very sophisticated software and really, really careful measurements and instrumentation to do this. It's really amazing. But there it is. Works well. Works really, really well. So yeah, if they looked at this spectral line, and they looked at another one. They looked at this one. Let's see, that's the one, helium-2 at 6560. This one.
Now, there's a sonatic if you go down of the paper.
A what?
A sonatic of the life dwarf.
Yeah. Anyway, yeah, so spectra tell you a lot of things. And like I said, we should probably do some live streams about this. That would help me, because spectroscopy is just hard. It's really complicated and really, really hard. And yeah, almost all these wiggles, almost all of them have some kind of significance, right? Some of this here, probably not, right? That's just noise. But, this thing, obviously, um, is a combination of a bunch of different elements. Carbon, aluminum, oxygen, sodium. Wow. So, and those seem to vary a little bit too. So, yeah, it's very, very cool. But I guess this is telling them sort of what the structure of this white dwarf might be based on those observations. Where's that picture? There it is. So this is how we're looking at it, like that. So that's what they're thinking. It's doing. So pretty cool. White dwarfs are pretty amazing things for sure. And I guess this only happens. This only happens with these hot white dwarfs. So white dwarfs that have a surface temperature of what, greater than 60,000 degrees Kelvin. That's pretty hot.
Yeah, and this one, it seemed that this one was kind of an outlier from what they had seen previously, so it kind of caught my attention.
Sweet.
And I found that miniseries. It was called The Inexplicable Universe. It was from 2012. I'll put a link in the Discord if you want to.
Okay, cool. Yeah.
Poke
What was
at
it called? What was it called?
It was called The Inexplicable Universe.
Inexplicable Universe.
Is that something you can get on Netflix or is on YouTube?
It's on Netflix.
Interesting. So
yeah.
When did he do that?
2012.
Okay, so not very long ago.
No, I thought it was longer. I thought it was further in the past.
Huh.
But
yeah. Cool. Yeah, I don't know if I ever knew about that. So nice.
I read one of the user reviews, and the user said, "Visually dull but intellectually stimulating." So
I can handle.
The ones I saw. Yeah, the ones I saw, he was pretty much just sitting in a chair on a set, and he walked around a little bit, but he didn't do too much. There wasn't a lot of graphics. He was mainly talking about different topics of astronomy and the universe.
Oh, nice. Yeah, I definitely want to see if I can check that out. That sounds more like what I would hope he would be doing. So yeah. So yeah, well, very, very cool. Let's see. I'm thinking this white dwarf stuff is very, very cool. I guess let's look at their conclusions here really quick. Share my screen again. Because yeah, I'd sort of like to see what they're thinking. So we report about the discovery of a new hot wind white dwarf, and I think these names are great, right? Because they tell us pretty exactly where it is in the sky, right? That's 1 hour, 46 minutes, right ascension, and then a positive 32 degrees, 36 minutes. So I think that's cool, right? Let's see. That reveal rapid changes of the equivalent widths of several UHE features, which are correlated with the star's rotational period. Weak magnetic field, which, yeah, That's yeah. I mean, I think that is weak in terms of white dwarfs, but the Earth's magnetic field is half of a Gauss, right? And maybe even a little bit less. So they're talking about 600 to 100 Gauss. So, and those are called weak. So, yeah, what an amazing place to be. Uh, yeah, it's hard to imagine being in that kind of environment. Because wow, I mean that's a magnetic field that's pretty nasty. Uh, anyway, yeah. So a wind-fed circumstellar magnetosphere. Wow, very cool. Okay, so let's see. The radiatively cooled and dense post-shocked material in the magnetosphere sporadically falls back into the stellar surface and constitutes an additional line-forming region for the variable too broad and too deep helium-2 lines. This is the first time that a wind-fed circumstellar magnetosphere around an apparently isolated white dwarf has been discovered. About 25% of all white dwarfs have weak magnetic field strengths of a few thousand Gauss, suggesting that indeed a substantial fraction of all stars may develop a wind-fed circumstellar magnetosphere during their early white dwarf cooling phase. Oh, cool. Further theoretical and observational efforts is therefore highly desirable for a profound understanding of the hot wind white dwarfs. Polarimetric observations may help to derive the magnetic field strength. Yeah, if you can measure the polarimetry of your light signal, that can give you a hint for sure. Cool. Yeah, so where are these guys out of? Looks like, I guess that was way at the bottom. I missed it. Cool. Oh, I guess I don't see their contact info, but it looks maybe German. I think that's probably a good guess. Maybe some Spaniards in there. Cool. Yeah, nice. Unraveling the baffling mystery. Yeah, I like it. But looks like they need more data, different kind of data, right? If you throw the polarimetry in there, that's going to add an interesting level of information. So, yeah, could be pretty interesting. Let's see, Bill. Nova Science Now. That's right. Yeah, he was on that as well, and he does a podcast, right? Space Talk. Is that what it's called?
Star Talk, from what I heard.
Star Talk. Okay. Yeah, I've tried to watch a few of those, and I just can't do it. So.
Well, I like the content when they're actually talking about things, but he and some of the guests that are on tend to try and make jokes a little too much for me, but they're in front of an audience and they're trying to entertain, I guess. Yeah. Well, I totally agree though that
That yeah, they're I think they're trying a little bit too hard, and uh, they probably know that, but the feedback that they get from the crowd is very positive, right? So if one receives positive feedback for something that you're doing, you tend to continue to do that. So yeah, I think it's fine. Yeah, but yeah, like I said, I think he's got a good heart, and I mean, he definitely knows his stuff, right? I mean, for sure, right? He's absolutely no joke. Um, um, in terms of that, he's a good scientist for sure. All right, well, cool. I think I'm going to call it for today. Have a little short session instead of the usual. So yeah, I think that's good for today. Definitely need to. I'm sort of itching for like a, I don't know, constellation of the day or object of the day or something. Um, yeah, yeah, I think I definitely want to do one of those. So let's plan on doing that tomorrow. Yeah, sounds good to me. So, all right, you guys, I'm going to get out of here. So, thanks for coming in again, joining the the crowd here. So, peace, cheers. Have a great evening, a great day, and I will see you in a little less than one Earth's rotation. All right, take care, everybody. Bye.
Later.